We are right in the middle of a defining moment for AI. There are these two massive breakthroughs that just dropped. And we're not talking about just little updates here. These are huge, fundamental shifts. And they're about to make some incredibly powerful AI tools way more accessible for a whole new wave of developers and creators. So, let's just dive right in.
So first, I want you to just think about this for a second. The high-end GPU in your computer, it's got thousands of tiny processors packed inside. It's basically a personal supercomputer. But here's the thing. For decades, actually telling it what to do has been wildly complicated. So what if that barrier? What if it just vanished?
Because, well, that's pretty much what's happening. After 20 years of doing things one way, a real tectonic shift is here. It's going to completely change how developers can get in there and unlock the true power of these machines.
And that brings us to our first huge breakthrough, and this one's from NVIDIA. Seriously, this is the biggest, most fundamental change to their programming model since they first came up with it way back in 2006. We are talking about a totally new way to program GPUs.
Okay, so to really get what's changed, we first need to know what we're changing from. CUDA. That's been NVIDIA's secret sauce for years. It's the programming model that lets you grab the reins of all those thousands of tiny processors inside a GPU and do amazing things. Everything from massive scientific calculations to running the AI models that we all talk about every single day. But here's the catch, right? For 2 whole decades, if you wanted to program with CUDA, you had to manually control every single one of those processors or threads. It meant you had to write the math to figure out what data each thread gets. You had to manage the memory yourself. It's powerful, for sure, but it is also insanely complicated for anyone who hasn't spent years living and breathing GPU architecture.
And conceptually, the change is just massive. The old way, it was like trying to be the micromanager for thousands of employees at once. It was super fine-grained, super complex. This new way, which is called CUDA Tile, is so much cleaner. Now you just work with these nice, organized chunks of data, these tiles, and the compiler, it automatically figures out how to split that work across all those thousands of threads for you.
And you can really see the difference when you look at the actual code. I mean, it's night and day. Before, programmers had to write these really complex math formulas just to tell a single thread what to work on, and then they'd have to manually check for errors that could crash the whole thing. With this new CUDA Tile, poof, all of that is gone. You work with whole chunks of data, and the compiler handles all those messy low-level details. And this is the real game changer. You can finally focus on your algorithm, not on wrestling with the hardware.
Okay, so that's a revolution in how we build AI. Now let's shift gears to our second breakthrough. This is all about building a more natural way to interact with AI. This one comes from Microsoft, and it's aimed squarely at getting rid of that awkward delay we always hear in AI voices.
This number right here, this is everything. About 300 milliseconds, that's roughly how long it takes Microsoft's new model, VibeVoice Realtime, to go from getting text to producing sound you can hear. Now, why is that such a big deal? Because it kills that unnatural, weird pause you get when a large language model finishes thinking and then starts talking. It lets the AI speak the moment that first word is ready to go.
And the way they pulled this off is pretty slick. The model itself is incredibly lightweight for what it does, just 500 million parameters. It's built for streaming, which means it chews on text in little chunks as they come in, and that's what enables the real-time output. Plus, it's so efficient it can run on a basic CPU, or even a free-tier GPU. That makes it super easy to deploy just about anywhere. The whole setup is beautifully simple, but really effective. Here's how it flows. Step 1, a language model processes the text into tokens. Step 2, this really efficient tokenizer turns those into a super compressed audio format. And then step 3, this is the key. A lightweight little diffusion head takes cues from the language model to predict the next little chunk of audio, creating this continuous, smooth stream of sound. It's building the speech piece by piece, not waiting for the whole sentence to be finished.
So, we've got 2 huge advancements here. One is making it way simpler to build things on supercomputers, and the other is making our chats with AI feel instant and natural. So what happens when you put those 2 ideas together?
When you really boil it down, what we're looking at are 2 really elegant solutions to 2 really big problems. On one hand, NVIDIA just tackled the insane complexity of GPUs by letting the compiler do all the hard work. That frees up developers to just focus on their ideas. And on the other hand, Microsoft solved that annoying AI voice lag by generating speech in real time. Both of these breakthroughs are really about the exact same thing: removing friction and lowering the barrier to entry for really powerful AI.
And ultimately, that's the big takeaway. The future of programming AI is simpler code with the same mind-blowing performance. And the future of interacting with AI is going to be more fluid, more natural than we've ever seen. These incredible tools are being put directly into the hands of more creators, more developers, more thinkers. So the only question left is, what are they going to build?